Hi everyone, welcome to 6th International Erosion Conference on Biological and Chemical Sciences. My name is Burak Malik Kaya. I participate in from Eskişehir Osman Gazi University. I will talk about set up a sensor network for multiple measurement by the Fiber Loop Ringdown Spectroscopy technique. Motivation was for this work, low cost and high sensitivity spectroscopic system design and application, easy setup, small volume, simple design, elasticity, monitor electromagnetic interference, advantages of fiber optic sensor, early diagnosis, portability, and sensor networking. I'd like to talk first sensor. What is a sensor? Sensor can detect changes in the media and transfer information to the other devices. Electronic and optical based sensors are available in the markets. Electronic sensors have several advantages, but one important disadvantage highly affected by electrical interference. This affects the sensor sensitivity actually. Optical sensors advantage is not flow dependent, process easier and faster, high accuracy and resolution, easy calibration, longer lifetime, high sensitivity, real-time measurement, portability, etc. Disadvantages: high precise working effort, initial system cost, and fragility of course. There are several types of fiber optic cables, multiple step index and grade index sensors, change input pulse, very obvious. Input pulse and output pulse are different in multi-mode step index and grade index. Single mode, only one type of signal propagates in the fiber, and input and output pulse doesn't change too much. That's why we use single mode in our studies. Fiber loop ringdown spectroscopy system figure shown in this presentation. We have electronic equipment at the beginning, and we have two couplers in the loop. Couplers can change the ratio of the trapped fiber, light pulse. It can be 9 to 60, 9 to 10, 90 to 10, 50 50, 60 40, 0.1 to 99.9. And a sensor head created in the middle of fiber by etching. From second coupler, a small portion of light sent to the detector. The single mode fiber structure shown in this part. In the middle, there is a core, cladding, and plastic jacket levels. Core 8.2, cladding 125, plastic jacket 250 micrometer radius. Light propagates in the core with a total reflection. Advantages and disadvantages of fiber optic. Advantages: immunity to electromagnetic, electric and magnetic fluctuations, small volume lightness and elasticity, wide band gap, that's why high data transmission capability, longer propagation distance, minimum data and energy loss, high durability to harsh environment, and wide range working temperature range. Disadvantages: high initial setup due to optomechanic components, high precision working effort for alignment, and fragility. This is cavity ringdown spectroscopy technique based on two high reflective mirrors. FLRDS, our used technique, was evolved from cavity ringdown spectroscopy technique. The intensity of light in the cavity changed exponentially. The principle of operation is based on the measurement of a decay rate rather than an absolute absorbance. The decay constant tau, which is the time taken for the intensity of light to fall to 1 over E of initial intensity, is called ringdown time, which is our key parameter to measure. Is dependent on the loss mechanism within the cavity. When we look at this slide, when we send a laser pulse, this pulse trapped in high reflective mirrors until it flows off, dies off. There are small signal to the photodetector. Each time we get lower intensity, and then we create ringdown time signal. Similar concept applied on fiber loop. In fiber loop, when we send a light pulse from the laser source, from couplers, very small portion will trapped in this fiber loop, and each time until this pulse dies off, a small portion from second coupler goes to detector. And each time when this pulse turns around the loop, in the sensor head, it will interface with measurements. That's why fiber loop ringdown spectroscopy technique allows very high sensitivity. This is our experimental setup in Eskişehir Osman Gazi University. At the beginning, our system signal to noise ratio is very high, and then arranging diode temperature, diode current, laser driver temperature and current, arrange loop parameters such as loop length, couplers, splice, losses, arrange oscilloscope parameters, and then software. After all this working effort, we get very low signal to noise ratio as shown in the figure. After that, with this technique, we published several works. Strain sensor, we designed a strain sensor, 80 centimeter sensor, stretched 12 centimeter, and then collect data. After that, 10 centimeter sensor, stretched 2 centimeter, and then after we collected data, we published in optical fiber technology in 2020. And different design. We designed sensor on the pipe and embedded this pipe into the sand in a box. When we applied pressure on the pipe, fiber optic received pressures, and then depends on pressure, experimental time, ringdown time changed in several loops, different loops, and we published in Turkish Journal of Electrical Engineering this work. Chemical sensor. After we create a sensor head by etching the fiber, we immersed into the DI water, tap water, salty water, and sugar water this sensor head, and we got several data and published in several journals. And these works was different with my current studies. These are my PhD studies. I'll pass through these studies faster. This is biosensor application. We tested DNA 1 and DNA 2 and DNA 3 application and bacteria application. And sensor network setup. When we set up a sensor network, we can connect in serial or parallel. When we connect in serial several loop, we got several data with working system. Loop 1 and loop 2 in water and air tested. And parallel configuration in this figure, when we connect loops in parallel, and in parallel we got another data with air and DI water. And we collect data, we showed sensors can be connected in series and parallel, and we can work with the system. And this system set up in Eskişehir Osman Gazi University Optics and Photonics Laboratory in Vocational School of Health Service. This is the first laboratory in Eskişehir actually. I connected two loops, I optimized my system, and then I connected two loops in series. I got software and two loops working in together simultaneously. I can collect data in real time, and simultaneous measurement can be figured out in our system. Loop 1 and loop 2, when we change strain, pressure, or surrounding media, when we etched sensor, when we change loop pressure, surrounding media refractive index, loop 1 and loop 2 feeding, experimental feeding, we can find the ringdown time of the sensor, of the loop actually. And in this case, it's stable, it's in stable situation. Loop 1, 140.92 microsecond ringdown time, and loop 2, 171.15 microsecond ringdown time. And two different loops, two different ringdown time. That's normal. And then when you apply any external parameter, we can change the ringdown time and collect the data. This is my experimental setup. Two loops connected in series, two detectors, oscilloscope, and my laser source, 1550 nanometer, continuous wave laser, and oscilloscope, function generator, computer, software design actually. In future, with this system, I'd like to enhance the sensitivity, lower the cost, getting project with target molecule sensing, portable ready-to-use system, simultaneous parameter measurement. Thank you for listening. Do you have any question?